Hello, once again. Today we have a question on heat engine. Once again, we have a question on heat engine. Let's read through the question given. Heat is added to an engine with air as working fluid. At constant volume, the temperature of air just before the heat addition is 27 degrees Celsius and it rises to 827 degrees Celsius after the constant volume heat addition process. The calorific or heating value of the fuel is 43,000 kilojoule per kilogram. Assume 40% combustion efficiency for the heat engine. Calculate the air to fuel ratio on a mass basis. Once again, calculate the air fuel ratio on the mass basis. Now, in this particular question, let's pull out all our parameters. We were given an heat engine with the T low, which is temperature 1, as 27 degrees Celsius, and the Ti, that is the high temperature, 82.7 degrees Celsius. And we're given the heating value of the fuel, 43,000 kilojoule per kilogram, and the combustion efficiency of the heat engine, known to be 40%, which will be 0.4. Now, our constant volume entity for our gas is 0.18 kilojoule per kilogram Kelvin, that is CV. Don't let us forget we are dealing with ID gas. Now, corresponding to this schematic diagram of an heat engine, whereby heat is passing to the heat engine from the high source to the low source, while work is being done outside. Now, by using the first thermodynamic equation, that is Q in equals W out, which is given here, our Q in for the constant heat addition process for an ID gas equals MaCV dt, that is the product of the mass of the air to the constant volume value to the temperature gradient, equals the percentage, that is the combustion percentage of the heat engine multiplied by the mass flow rate of the fuel multiplied by the heating value of the fuel. So therefore, our Q in equals W out equals MaCV delta T equals efficiency of the fuel multiplied by the mass flow rate of the fuel multiplied by the heating value. So therefore, by pulling out our air fuel ratio, which is Ma over F, from our reference equation here, we have Ma over F to be efficiency multiplied by HV over CV dt. So that gives us this particular value. From there, our calculated mass to fuel ratio becomes 29.94. So therefore, our calculated air to mass ratios for this particular heat engine operating under constant volume heat addition process equals 29.94. Thank you very much.